All right, this is a supplemental recording of question number 4 in the practice exam. All right, so I got the whole program, input into this spreadsheet here. Column A is the line number column, and then column B is the actual program. And I will show you guys how to trace this program as you execute it in the spreadsheet. Okay. Um, so the most important part about this particular program is what is on line 6. The format string on line 6 has %d, comma %d, which means scanf is expecting a base 10 integer followed by a comma and then another base 10 integer. And the algorithm uses a greedy algorithm, which means it will try to match as many characters to an integer as possible. Alright, so given that, let's go ahead and start a trace. I will use a new sheet. Actually, I'm going to use sheet 2 as the trace, and we'll open a new window so we can display both the trace and also the program at the same time. And let me get everything resized. Okay, so this way we can show both. I can show both the program and the trace at the same time, or at least, as much as I can. All right, there we go. So in sheet 2, we have the trace. The program starts execution in main. And I put this here because that's the actual input. Using the example in class, the student ID is 1, 2, oops, 3, 4, and the 5 here. A 6 over here. Let's see. A 6 over here and a 7 over here. So that's the actual input. I keep it here just so that I can see. I can keep seeing that part. In the main program, we only have one single local variable, which is x. So x is going to have its own column, and it starts off as an uninitialized value, which means it's going to be represented by a question mark. I need 2 additional columns here. There we go. Okay, the first one is called comments, and we'll definitely start to use it when we need to. And then the second one is line number. That indicates at what line we're doing what in the program. This is the initial condition because main is called from outside. We don't know exactly the line number of the call to main. Now we can start execution in main, starting on line 20. X gets a value of 0, and we can make columns a little bit shorter or narrower, so this way it doesn't interfere with the other columns as much. On line 21, we evaluate the condition. Basically, we want to find out whether sum is returning a value that is greater than or equal to 0. Now, this is the tricky part. This is the part where I have not really talked about it in this class because, in cisp360, the instructor is supposed to go over how to trace a program with subroutine calls like this. All right, so let me just kind of explain how this works. On this particular line, on line 21, what we do is we use a column called return info and not return line number, because when we come back from the invocation, this line is not done yet. There are other things to do on this line, and that's why it's called return info and not return line number. And then inside the return info cell, we indicate this is on line 21. It is a while, and then the tricky part is the sum or the call invocation to sum is replaced by a single question mark. Everything else will just type it as is on that particular line. So that's why return info looks like this, because the call to sum is the only part that is replaced by question mark. The question mark is acting as a placeholder to indicate the return value of the subroutine goes here. Now, just like any other subroutine call, we also need columns for local variables as well as parameters. In this case, sum has one parameter, which is a pointer, and it also has 3 local variables, r, x, and y. So we'll allocate columns for those things. So pr is a parameter, r is a local variable, and so are x and y. The local variables are easy to deal with because they all start with unknown values, and I use the question mark to indicate that those are unknown. PR, on the other hand, is a little tricky because the argument is the address of x. Now, the address of x, and x is a local variable of main is column C. So that's why, as a parameter, we just say C column C. There we go. So now we have set up the appropriate parameters, and also local variables. Now we can proceed and start execution inside the subroutine. Inside the subroutine sum, the first line to execute is line 6. Oops, wrong line. Okay, let me undo this part. Okay, so line 6 is the next line to execute. And line 6 is a while line, so we have to indicate what we're getting on that line. So we say while. Now the next question is whether the condition is true or not. Well, actually I don't indicate while here, we just indicate the condition. The scanf is trying to read two integers separated by a comma. At this point we are reading the letter A, which means it is not going to match even the first %d or the first integer. So it's going to fail. And the end result is R would get a value of 0 because we are not reading anything that scanf requests, but we still have the negation symbol on the outside. Now, because in an assignment expression, the actual value of the expression is the right hand side of the assignment, so that means we are taking the negation of 0. 0 also means false, not false is true, so we say this is actually true. Now when that is true, we get something that's even more interesting because we have to get into the loop. The loop itself has another local variable ch, so we'll allocate on line, well, I guess we can do it here. So we'll allocate another column for ch right here. So we say that ch is going to start with an unknown value. And then on line 9, we will attempt to read one single character. When we read a single character, as long as the file is not at end of file, it is always successful. So in this case, it's going to read the character A, and I'm going to use quote A quote to indicate char has the ASCII code of A. And then after line 9, we go back to line 6. Okay. Now at this point, A is already read, so we are left with 12, comma, and then R34. The attempt to read an integer first, and then a comma and an integer, it's only going to be partially failing. In other words, in this particular case, when we get back to line 6, R is going to get a value of 1 because scanf returns a 1 because it did read one single integer and a comma, but it will fail to read the second integer. The negation of R equals 1 is the negation of true because any value other than 0 is true, and that is false. So that means we're going to get out of this loop here. When we get out of the loop, we continue execution on line 11. Line 11 has its own condition to evaluate, which is R is greater than or equal to 1. That is true because R is actually 1. Then we have to execute line 13. Line 13 has to first evaluate whether R equals to 1, and the answer is yes, R does equal to 1. Oh, I forgot to do one thing, because when we get to line 6, when we attempted to read the integer, the value 12 should now be stored in local variable x, because that's where it's reading it into. So we have a 12 here. Alright, sorry about that, I forgot about the side effect of the scanf statement, and that is the side effect of line 6. So now on line 13, we are going to add the value of x to whatever PR is pointing to. PR points to column C. Column C currently has a value of 0. So we're basically adding the value of x, which is 12, to the value in column C. So column C is now updated to a value of 12. And at that point, we get out of the conditional statement. We get to line 15. This is the other part where it is kind of really tricky because it's not just tedious, it is kind of tricky. At this point, the subroutine is done and is ready to return, but it's also going to return a value. What we're going to do is to return the value that's going to take the place of the question mark. So what I do is I copy and paste the return info cell, okay, and change the question mark to the value that we are actually returning. In this case, we are returning the value of R. Ooh, you know what? I kept forgetting that R is also getting updated on line 6. So we have to backfill that. Okay. So the second time R gets a value of 1. So that means the return value is actually 1. Okay. But the return value is just replacing the question mark, which is the placeholder of the return value. After that, we execute line 16. Line 16 is concluding this subroutine is all done. So what we'll do is deallocate all the local variables. CH actually would be deallocated as well. So I'm going to copy and paste all of these columns here along with CH. And we'll indicate these are no longer in use. And I usually use the strike through indication. There you go. So now these are all deallocated. And after line 16, which is the end of the subroutine, we continue execution based on the return info cell here. The return info cell tells us that we have to go to line 21. But on line 21, the condition is now just 1 is greater than or equal to 0 because the invocation is replaced by a value of 1. 1 is greater than or equal to 0 is obviously true. And because it's true, we're going to print the value of x on line 22. So on line 22, we'll just say that this is what we're going to print. We're going to print x equal to 12 because x currently has a value of 12 here. And then we go back onto line 21. When we go back on line 21, we'll do everything all over again, which basically means we are going to call the subroutine again. And whenever we call a subroutine, we have to set up all the columns. So basically, we set up all of these columns all over again. And the return info cell is exactly the same as before because it's being called from the same place. And the other parameters and stuff like that would also be the same because the local variables remain uninitialized and the parameter is still referring to column C because we are still using the address of X to call it. Then we get into the subroutine starting on line 6. Line 6 will attempt to read an integer followed by a comma followed by another integer. This time we stop at the R because the comma would have read. So the R is going to make the scanf fail because we don't even have a single integer to read. So that means several things. R is the expression itself is R gets a value of 0. But because 0 means false, not false is true. And as a result, R is also updated to a value of 0 here. Then we proceed to line 9, but before we get there, we have to allocate for CH. So we say CH is a local variable allocated at this point. And then we get to line 9. Line 9 is only reading a character. In this case, it's going to read the character R. And then it's basically immediately forgotten. We go back to line 6. So on line 6 now we have 34, 5 CD. As I said, scanf is a greedy algorithm. It will read 34. It will match 34 to an integer. It will match the comma. It will match the 5 to another integer, and will stop on the C and on the C character here. So that means this time R would actually get a value of 2 because scanf successfully reads back 2 value. 2 is non-zero and non-zero is true, not true is false. But at the same time, we also have to remember that R is now updated to a value of 2 because we assigned the result of scanf to R. But at the same time, X and Y are both updated this time X is updated to a value of 34, Y is updated to a value of 5. After line 6, we continue to line 11 because the condition is false. That makes us exit the loop. On line 12, R is greater than or equal to 1 is actually true because R has a value of 2, and that makes us continue onto line 13. On line 13, we are going to first evaluate whether R equals to 1. R does not equal to 1 because R has a value of 2, which means we'll choose the third expression in the ternary operator, which is x plus y. X is 34, y is 5. 34 plus 5 is 39. And 39 is added, not just stored, but added to whatever value the PR is pointing to. PR is pointing to column C. Column C currently has a value of 12, so we're basically adding 12 to 39, and that should be 51. So right here on line 13, column C is going to be updated to 51. After that, we go to line 15. Line 15 is a return statement, so we do pretty much the same thing as before. Copy and paste the return info cell, change the question mark to the value that is being returned, which is 51. Oh, wait, hold on a second. It's returning R. R has a value of 2, so we're just changing the question mark to a value of 2. And we don't do a single thing about line 21 here. All we do is to change the question mark to the value that we are returning because we're indicating the invocation of the subroutine has a value of 2 in this case. And then on line 16, we deallocate everything just like last time. So all of these columns are now deallocated. Once a column is deallocated, it can be reallocated in the following code. After line 16, we continue on to line 21. Line 21 currently looks like this because the invocation of sum is now replaced by the return value of 2. So we just basically say 2 is greater than or equal to 0 is true. So we continue on to line 23 again. Line 23 is just printing x equals to something. So we say print x equals to 51 in this case. And now we go back onto line 21. And on line 21, we are invoking the subroutine again. So we basically repeat all of this stuff again. So I'm getting lazy and just copy and paste it. And then after that, we go to line 6 inside the subroutine. And on line 6 of the subroutine, once again, we are attempting to read two integers separated by a comma. And right now, we are stopping at a C and a D. And at this point, it's going to fail because C and D are both. C is not the beginning of an integer. D is not the beginning of an integer. Exclamation point is not the beginning of an integer. Space is not the beginning of an integer. So we'll basically skip all the way until we read 6 and 7. I'm just going to skip a whole bunch of stuff now. So eventually, it's going to read 6 and 7. Once it reads 6 and 7, it will get out of the loop. And we'll add 13 basically to what PR points to. So I'm going to put some ... here to accelerate the process, to skip it. So eventually on line 13, we end up adding 13, which is 6 plus 7 to 51. So 13 plus 51 is 64. And then on line 15, we will return a value of 2 because that's the last thing we successfully read would be 6 and 7. So it will replace the question mark with the value of 2 here. And then on line 16, we deallocate all the columns, just like that. And then we continue execution based on the last or the rightmost return info cell, which is onto line 21 because of this. And then on line 21, we are going to say 2 is greater than or equal to 0 is true. And then on line 23, it prints the new value. Oh, I forgot one thing. No, I did not. Okay, never mind. So it's going to print x equals to 64 this time. And then we'll go back onto line 21. Now, remember, this is the end of the entire file already. So you know that this time, when we get into the subroutine, Okay, so I'm just going to do the whole thing again. Okay, but this is going to be the last time. We'll start with line 6 again, but this time on line 6, X would, excuse me, scanf returns -1 because it's at end of file. At end of file, scanf returns -1, so that means we have the negation here, r equals -1. -1 is not 0. Anything that is not 0 is considered true. Not true is false. So that means we fall out of the loop immediately. But we do have to remember to update r. R has a value of -1. So after line 6, we go straight to line 11. On line 11, the condition is r is greater than or equal to 1, but since r is -1, this condition is false. That means we don't do a single thing inside the conditional statement. Then we skip all the way to line 15. Line 15 is specifying the return value. We copy and paste the return info cell, change the question mark to the value that we are returning, which is -1 in this case. But we don't do a single thing about a while statement because this is not the time to do it. Then we proceed on to line 16. We deallocate all the columns here. And then we continue execution on line 21 based on the return info cell. So on line 21, the condition is -1 is greater than or -1 is greater than or equal to 0, and that is false. So we are done with the loop here. We skip all the way to line 25, and that's gonna we can stop here because we don't really know exactly where is the caller of main or what it is going to do with the value of 0. So we can stop on line 25. So the actual output of this program is going to be x equals 12, x equals 51, and x equals 64. Now let's see if that really is the case. So I'm going to copy all of this and see if we can put it inside a terminal. So let me start a terminal first. That's not a good one. Let's try something else. Okay, that's better. I just need the font to be a little bit bigger. Let's go to the temp folder, create this file. We'll call this q4.cpp because it's question number 4, and paste the program into it. Indentations are all wrong here, but that's okay. And then we'll create a file with just the same specification as what we have here, which is in this cell. Copy it and switch to the terminal. Let me switch to the terminal here. This is output.txt, and then we paste. Oops, it's actually the input, so let's name the file correctly. Input.txt, paste it like that, and then do a Control D. Okay. Alright, so now we have the input file and we have the program. Let's do a g++-o q4.cpp, compile the program first, and then we can now run the program q4, redirect from input.txt, and you can see the output is exactly x equals 12, x equals 51, and also x equals 64. So that's kind of the solution of question number 4. Alright, now that we have figured out the answer of question number 4, in this class I do not need you to give me a trace like this, which is very time consuming. But what you can do is to use the trace to figure out what the subroutine sum is actually doing. Because once you know what sum is doing, you can kind of not trace it and still be able to track down what it is going to do, which is 2 things. One, it is going to update whatever PR points to based on whether it read a number or 2 numbers. If it only read 1 number, it will just add that one number. If it read 2 numbers, it will add the sum of those 2 numbers to whatever PR points to. And then the second thing that sum does is it returns the number of items that it actually read. Now, if you think about it, it can only return -1, which means it has reached a file, 1, which means it read a single integer, or 2, that it read two integers. It cannot return a 0, because if r is 0, it will keep looping through this loop here and clear out all the characters. So that means, sum as a subroutine can only return -1, 1, or 2. But the side effect of the subroutine is it will also add whatever integer or integers that it has read to whatever PR points to. But PR is based on ampersand x, which is the address of x. In other words, sum as a subroutine is it just keeps adding to local variable x of main as it reads integers. But each time it will only read up to two characters. Excuse me, it will only read up to two integers, because as soon as it has read at least one integer, it will get out of the while loop, and that's why it is not going to read multiple. It will not read and process more than two integers. So I hope this kind of help you understand question number 4, and also how a trace is done. I can upload the trace if you want to, but otherwise, this is the whole video. I hope you find this useful.